Good morning, my dear students. Today we are going to learn single linked list operations in third unit. Okay, all of you. So, so these are the contents in the third unit. In the last class, so we learned pointers, point to arrays, linked list, node representation. Okay, today I'm going to give the demo on linked list. Okay, and its operations. All of you. Okay, so how many types of linked lists? How many types of linked lists? There are mainly four types of linked lists. Mainly four types of linked lists. So the first one is single linked list. Second one is double linked list. Third one is circular single linked list. And the fourth one is circularly double linked list. These are the four types of linked lists. The first one is the most important. So in end examination, they will ask write and explain single linked list operations with example. Okay. So simply, what is a single linked list? Simply, single linked list means chain. Single linked list means chain. So then those are connecting links like gold chain. So the first circle link connected to the second circle link. Next one, next one, next one. And also the general example is compartments in the train compartments. So they are collecting compartments, all the compartments. The first one engine to next equal to next compartment, that is connected to engine and next. So next compartment to next compartment to next. Totally they are connecting 10 to 20 compartments. So that is called single linked list. So the first engine link that is connected to the next compartment. Next compartment link connected to the next compartment. Last compartment, for example, guard to next compartment. Is there any compartment available? No. So that is null. Guard to next equal to null. Here also in single linked list or in the chains, a single linked list is also called a chain. A single linked list is also called a chain. Is a linked list in which each node represents one element. Clear? Each node represents one element. The operations we can perform only single linked list are insertion, deletion, and traversal. What are the operations in single linked list? So there are mainly three operations. The first one is insertion operation, second one is deletion operation, and the third one is traversal operation. So insertion operation, this is used to insert an element at the beginning of the list, at the end of the list, or anywhere in the list. Okay, in three ways. Then the delete operation is also same as the insertion. Same as insertion means we can delete an element from the beginning of the list. We can delete an element from the end of the list. We can delete an element anywhere from the list. Clear? So and the traversal means display all the elements from starting to header node to last node. Okay, traversal means to display all elements. So these three are the operations in single linked list. So then a single linked list is also called as one-way list. A single linked list is also called as one-way list. One-way list. So like this is one way. This is start. So for example, this is start. This is the next node and the next node. This is called one-way list. The arrow indicates here start to header node to next node to next last node. So that's why this is called one-way list. That's why this is called one-way list. Clear, all of you? So then this is called node. This is called node. So this node have two parts. How many parts it has? Two parts. The first part is the data part. Then the next part is the link part. That is called the next part. So then this is connected to the next node. So next node. So here also, this is also two parts. The first part is the data part, and the next part is the link part. So link means that is the next. It shows the address of the, it holds the address of the next node. Clear? Then this is also two parts. The first one is 30, and the link node. Then there is then there is no next node. That's why. So we will assign. We should assign null to the last node to next. Last node to next equal to null. Clear? So how many nodes are there? Here three nodes. Here simply 10, 20, 30. These are the data parts, data elements. Then this is used to, this part is used to show the next node address. That means that is a link between two nodes. Then this is also link between two nodes. So here the flow. So this is the arrow shows the flow directions. That's why this is called one-way list. Clear? This the flow directions from here to here, here to here, one-way list. Clear, all of you? How to create a node? What is the general syntax of the creating a node? The node of single linked list contains two fields. The first, all of you, data field and the next field. So here the node of single linked list contains how many fields? Two fields. The first field is called data field, and the second field is called next field. And the first field is called data field, and the second field is called next field. So data field is used to maintain the data element, and the next is pointer which points to the next node. Clear, all of you? So data field is used to maintain the data element, and the next and next field is pointing to, is pointer which is pointing to the next node, which is pointing to the next node. Clear? Each node has only one next field, and the last node has a null. So each node has the only one next field, and the last node have the null. Clear? Next field have the null. Clear, all of you? So then the next one, here definition of node. So here struct integer data node asterisk next. This is a pointer variable. It holds the address of the another variable. Clear, all of you? Then this is data part. This is called node. Integer data is an integer data type. Next is a pointer variable. Clear? Pointer variable. So simply node have how many parts? Two parts. The first part is the data part, and the next part is the address part. Clear? This is the definition of node. Clear, all of you? Struct begin integer data node star next, then close. So then operations of a single linked list are chain. Operations of single linked list are chain. So how many operations are there? The following are the operations in single linked list. How many? There are three types of operations. The first one is insertion, second one is deletion, third one is display. So insertion, deletion, display. Display is also called traversing. Insertion operations. In a single linked list, the insertion operation can be performed in three ways. They are as follows: inserting at beginning of the list, inserting at end of the list, inserting at a specific location in the list. Clear? Inserting at a specific location in the list. These are the operations, insert operations. Clear? Inserting at beginning of the list, inserting at end of the list, inserting at specific location in the list, anywhere in the list. Clear? So these are the operations, mainly three operations in single linked list. Those are insert, delete, and display or traversing. So insert operations here also, then we can insert an element in three ways. The first one is inserting at the beginning of the list, inserting at the end of the list, and inserting at specific location on the list. Clear? So inserting at the beginning of the list, inserting at the beginning of the list, we can use the following steps to insert a new node at the beginning of the single linked list. Let's start is pointer which points to the first node. So this is called start or begin or header node. Clear? So here start. Let start is pointer which points to the first node. This is a pointer which points to the first node. Here step one, create a new node called temp. create a new node called temp. Temp to data equal to value, that is 10. Here temp to next equal to start. Then this is called start. Start equal to temp. Then temp equal to start. Temp start. Then these two are the new node. These two are pointing to the same node. That is the first node. Here example, before insert new node at beginning, the list is, so for example, this is the list. So this is the list. So before I want to insert an element at the beginning of the list. This is actual list. This is actual list. I want to insert an element beginning of the list. Then after the insert new node at beginning, that this is new node. This is the temporary node. This is also start. Here 5. So this temporary to next equal to, so then here start, then start equal to temp. Here the first one, here start and temp moves. It shows same node. Then insert at beginning of the list. Clear? I will explain tomorrow using board. So all of you, I will explain examples how to insert an element at the beginning of the list, how to insert an element at the end of the list, and how to insert an element anywhere in the list. So I will give the example using board tomorrow class. Tomorrow I will give the example. Clear? So next one is inserting at end of the list. Same here simply, this is the original list. So when we can use the following steps to insert a new node at the end of the single linked list. Let start is pointer which points to the first node. Start is a pointer which points to the first node. We know same previous. Then create a new node called temp. Temp to data equal to value. And temp to next equal to null. Temp to next equal to null. Last equal to start. Same last equal to start. While last to next not equal to null. Last to next not equal to null. So if not equal to null, then traverse one by one elements. When null is occurred, last equal to last to next. Last equal to last to next. Then the next one, last to next equal to temp. Already we created one temporary variable. Last to next equal to temp. Clear? Last to next equal to temp. So then this is the before inserting new node at end of the single linked list. Then this is after inserting new node at end of the insert. Clear? This is the new node. This is inserted. New node to next equal to null. That is temp to next equal to null. Clear? Then last equal to temp. Last equal to temp. Clear? Last to next equal to temp. Then so last equal to temp. Clear all of you? Then here start. Then this is last. Then here start. Start to data 10. Then where start equal to start to next. Then start to data equal 20. Where start equal to start to next. Then start to next data equal to 30. Then start equal to start to next. Start to data equal to 40. Then start to next equal to, is there any link? Null. If it is null, then control exits. Then there is no element in the list. That is called a traverse. So inserting at specific location in the list. So which location you want to insert an element? For example, I want to insert an element at second location, 0, 1, 2, second location. Then you create a new node temp, temp to next equal to n, then p to next equal temp. Before inserting a new node, this is the single linked list. Before inserting the new node, this is the single linked list. Then inserting a new node at third node, then this is the after inserting. So anywhere in the list after inserting the second position. Here, this is for example, here current to next equal to temp, next to temp equal current to next to next. Then this is the, so inserting new node at third node. I will give the explanation in tomorrow using board. Okay, all of you, just listen only. Okay, I will give Blackboard example tomorrow. Okay, then how many operations in single linked list? Insert operations 3 ways. We can insert an element into the single linked list. So 3 ways. The first one is inserting at the beginning of the list. Second one, inserting at the end of the list, and inserting at a specific location in the list. Clear? So then inserting at the beginning of the list. Clear? This is an example. So then inserting at the end of the list. This is an example. Inserting at any specific location in the list. This is an example. Clear? Then deletion operations in single linked list. Deletion operations in single linked list. In a single linked list, the deletion operation can be performed in 3 ways. They are as follows. deleting from beginning of the list, deleting from end of the list, deleting from a specific node, same as the insertion. So deleting from the beginning of the list. We can use the following steps to delete a node from beginning of the single linked list. Step 1, temp equal to start, where start equal to start to next, where start equal to start to next. Then free node temp from memory. Before deleting a node, single linked list is, for example, this is the single linked list, 10, 20, 30, and 40. These are the elements. I want to remove 10 from this list. Clear? Here, then where is the start? This one is the start. Then here start equal to start to next. Here start equal to, then assignment operator equal to start to next. Then here control moves from here to here, then start. Then this link is disconnected. This link is disconnected. Then here, now start is here. Then simply it remove the element 10. So then deleting from end of the list, we can use the following steps to delete a node from end of the single linked list. Here step 1, last equal to start, last equal to start. For example, here this is the last equal to start, we assume. While last to next not equal to null, last to next not equal to null, no. So then previous equal to last, then previous equal to last, last equal to last to next, then control moves here. Then until repeat null, when the repeat is null, then previous to next equal to null. Here previous, then this one is the previous 30. Previous to next equal to null. So previous to next equal to null. Then simply this link is disconnected. I mean here 40 is removed. This is previous node. Previous to next equal to null. Clear? Then free last node from memory. This is free. Free means delete last node from the memory. Then before delete the last node, this is the linked list. After delete the last node, this is the linked list. Clear? Next one is deleting a specific node from the list. Deleting a specific node from the list. So I want to delete second element. Second element. Here simply, so we can use the following steps to delete a specific node from the single linked list. Let n is the node to be deleted and p is its previous node. Here previous to next equal to n to next. Previous to next equal to n to next. Then here previous to next equal to n to next. I mean, then simply here free node n from memory. Here previous to next equal to n to next. This is previous. Previous to next equal to, this is n. N to next equal to this one. I mean, this address assigned into this one. Simply it is disconnected. This is disconnected. Clear? So remove the element from the memory. So free the element from the memory. Specific node. Clear all of you? Displaying a single linked list or traversing a single linked list. Here while we can use the following steps to display the elements of a single linked list. Is last equal to start, last equal to start, while last not equal to null, while last not equal to null, print last to data, last equal to last to next. When the null is occurred, then stop the process. Clear? So they here simply this is used to display all the elements from the single linked list. Clear? All of you. So simply these are all the operations on single linked list. Next, double linked list. All of you. So then tomorrow I will give the Blackboard explanation of single linked list, double linked list, circular linked list, and circular double linked list. Tomorrow I will give explanation. Okay. So using Blackboard. Today this is only just what are the steps involved in the single linked list. We learn it. Okay. So tomorrow I will give in detail. Clear all of you? So then deleting from end of the list. So then a single linked list. What are the operations in single linked list? Operations in single linked list are chain. So the following are the operations of single linked list. The first one is insertion, deletion, and display. Insertion, deletion, and display. Display means traversal. So traversal, display all elements from the list or in the list. Inserting operation, we can insert an element in three ways. At the beginning of the list, we can insert an element at the beginning of the list. We can insert an element at the end of the list. We can insert an element at any specific location, anywhere in the list. So inserting, this is an example for inserting. Next one, inserting at the end of the list. We can use the following steps to insert a new node at the end of the single linked list. Here start to pointer which points to the first, inserting at the end of the list. This is an example for end of the list. Next one, inserting at a specific location, middle of the list, its second position. Okay. Next one is the deletion operations in single linked list. Here also we can delete an element from in previous. The first one is from the linked list. We can delete an element from the single linked list in the three ways. The first one is deleting from beginning of the list. Second one is deleting from end of the list, and third one is deleting a specific node. So this is an example for deleting an element from the beginning of the list. This is an example to delete an element at the end of the list. This is an example, delete an element from the list anywhere in the list. Okay, any specific location from the list. Clear? These are the operations. This is the display operation. Next one is double linked list. What is double linked list? What is the difference between single linked list and double linked list? Clear, all of you? So 2 marks question. Differences between single linked list and double linked list. Single linked list, it is a one-way linked list. Remember, all of you, it is a one-way linked list. Whereas double linked list, it is a two-way linked list. Your forward traversal and backward traversal is available in the double linked list. That is an advantage. Your forward and backward traversals. So then, whereas in single linked, that is only forward traversal is available. Then there is no backward traversal. Clear? So in a double linked list, each node contains 2 pointers. The first pointer points to the previous node and the next pointer points to the next node. So that's why this is called double linked list. In a double linked list operations, in the double linked list, each node have 3 parts. Node have 3 parts. I mean here 2 pointers. The first part represents the previous. The first pointer represents the previous, or it holds the previous node address. Next pointer, it holds the address of the next node address. Clear? In a double linked list, each node contains 2 pointers. In a double linked list, each node have 3 parts. The first part is the previous, next part is the data, and the last part is the next. Okay, so this is the previous, this is the data part, and this is the next part. The previous part, it shows the address of the previous node. It shows the address of the next node. Clear? That's why this is like this directions. Clear? This directions. Okay, previous and next. So it is the two-way list. It is the two-way list. We can move from left to right and right to left. We can move from left to right and right to left. The control move from left to right and right to left. So then node structure. Double linked list has sequence of nodes, and each node has 3 fields. Each node has 3 fields. How many fields? 3 fields. Here previous field, data field, and the next field. This is a node. So previous, it is a pointer linked to point to the previous node. It is a pointer, so it is used to point the previous node. So next one is data part. So then the data field is, it is used to store the data. It is used to store the data. Then the next field in the node, it is a pointer. This is a link to point to the next node. It is a pointer. It is also pointing to the next node. Clear? Previous is pointing to the previous node. Next is pointing to the next node. Then data, it holds the value. Clear? So this is the double linked list. How to create a double linked list? Here node structure declaration. In the double linked list, a node can define using class, using in structure, using in using C. So then using C, here node. So this is struct node, then node asterisk previous. This is a pointer variable, integer data, and node asterisk next. Okay. Here node, what is a node? This is same as class structure name. This is same as structure name. Here previous is a structure type pointer variable. Simply it holds the address of the another structure variable. So node is also a pointer variable. It holds the address of the another structure variable. Clear? So that's why here node asterisk previous. Node is a structure data. Clear? Data member. Node asterisk previous, then node asterisk star next integer data. So this is the following is a double linked list with the elements 10, 20 and 10, 20, 30 and 40. This is how to create a double linked list. So for example, here creating a node, that is start node, node to previous equal to null, because then there is no previous node. Then node to data equal to 10, the first element assigned into this one. Here node to next equal to node to next equal to new node. Then new node to previous equal to start node. Then the next one, so 20 insert into the new node. Again, this is the another node to next previous equal to previous node. Then the previous node to next equal to another node. Then another node to data equal to 30, like this. The last node to next equal to null. The last node to next equal to null. So how many nulls here? Here the first node to previous equal to null and the last node to next equal to null. Clear? All of you? Then here we will go this way and we will return back also this way. So this is an advantage of double linked list. Here backward and forward traversals are available. Left to right and right to left traversal is available. That is an advantage. Whereas in single linked list, only one-way traversal. This is a two-way list. That is one-way list. Clear? So then operations on double linked list. So possible operations on double linked list are insert. So same as single linked list. Insert a new node at the beginning, insert a new node at the end, insert a new node at specific location. Clear? So next one is deletion. Delete a new node at the beginning, delete a new node at the end, delete a new node at specific location. Displaying traversal, display from left to right and display from right to left. Clear? From left to right and right to left. Then search operation is also one of the operation. We want to search an element. So particular element the list have or not. So go to search option. That is also equal to traversal. Then insertion in a double linked list. In a double linked list, the insertion operation can be performed in three ways. Same. Insert a new node at the beginning of the list, insert a new node at end of the list, insert a new node at a specific location. Insert a new node at the beginning of the list. The following is the logic to insert a new node at the beginning. Start is pointing to the first node. You create new node temp. Temp to next equal to start, temp to previous equal to null. Here start equal to temp. Remember all of you. You temp to next equal to start. Here temp to next equal to start. This is start. Clear? Temp to previous equal to temp to previous. This is temporary. Temporary to previous equal to null. Clear? Temporary to previous equal to null. Next one is temporary to previous equal null. Start equal to temp. Then start position move from here to here. Then start equal to temp. Next now start and temp pointing to the same location. Clear? So I will explain tomorrow class using board. Clear? Next, insert a new node at end. Insert a new node at end. The following is the logic. Insert a new node at the end. Here, create a new node. First, we want to create a new node. This is called temp. Temp to previous equal to next. This is temp to previous equal to last node next. Then last to next equal to temp. Last to next equal to temp. Where last equal to temp. Last equal to temp. Then the last pointer and the temp pointer pointing to the same node. Clear? So then this is a insert a new node at the end. So insert a new node at the middle of the list. Here simply which position you want to insert. For example, second position. Then create a temporary node. Temporary to previous equal to then this node. Temporary to next equal to this node. This node to next previous equal to temporary. Okay. Then next one is this one same. Then there is no change. But inserting elements, links, connecting links between these two. Okay. Insert. I will explain in using tomorrow. Okay. Using board. Clear? Next one is delete double linked list. So then here also there are three ways to delete an element from the double linked list. Delete a new node at the beginning of the linked list, delete a new node at the end of the linked list, delete a new node at specific location. So then here beginning, this node we want to remove. Here start equal to start to next. So then this is the start, then start to previous equal to null. Then, so this is removed. Clear? And next one is end of the list. Here last equal to last to previous. Then the move control moves here. Then the last to next equal to null. Then this is disconnected. Clear? So next one is deleting a node at any position. This node I want to. So this one to next equal to this one to next equal to next to temporary previous equal to previous this one. Simply this is removed. Clear? So then these are the operations, delete operations in a double linked list. Display operation we know, so from right to left to right. Temp not equal to null, print temp to data where temp equal to temp to next until all the elements are visited and displayed one by one. Then when the null is occurred, then stop the here from temp equal to last to beginning. So this is also used to display from right to left traversion, two types of traversion. Clear? Circular view. Then next class we will discuss. So tomorrow I will give example using word, okay, on single linked list and double linked list. All of you clear? Just listen today. Tomorrow I will explain. So I hope you will understand. Clear? All of you. Thank you.